Okay, so these notes start on page 192, and this is the start of our predicting notes. And we're just going to start off with synthesis, decomp, and composition, and then we'll do single and double last, okay? So if we remember, synthesis reactions make one product, okay? So we can have three different synthesis reactions that we could come across and that we have to be able to identify. Okay, the first one is just an element plus an element coming together and making a binary compound. So let's look at a couple of examples here. So we have copper and sulfur, and they're coming together, and we're just going to assume that copper is +2 here. So we're going to make copper sulfide, and that's our substance, okay? That seems pretty easy, okay? Now look at the second one. This is how your predictions will actually start to look like once we get the hang of this, okay? So we have beryllium and oxygen, which means we're probably going to be making beryllium oxide. Okay, so beryllium is Be, okay, plus you have to remember that oxygen is a Hofbrinkel, so we need O2, and we're going to make beryllium oxide, okay? Beryllium's charge, and when I do this, I'm going to say beryllium's charge is +2, oxygen's charge is -2, so they cancel each other out. So I'm going to have beryllium oxide as BeO. And then I need to make sure that I balance, okay? So I have 2 oxygens here, 1 here. So I need to put a 2 here and then a 2 in front of beryllium. Okay, that's the first type of synthesis reaction. The second type of synthesis reaction is when we have a metal oxide, okay? So a metal attached to an oxygen inside of water, and we're going to make a metal hydroxide. So whatever metal was attached to the oxygen is going to become metal and then hydroxide attached to it, okay? So for example, we have magnesium oxide, so metal oxide plus water, which means my product is going to be magnesium hydroxide, okay? So magnesium is Mg +2, and hydroxide is -1. Charges don't cancel, so my product is going to be MgOH2, okay? And then the last thing I need to do is to make sure it's balanced, and it looks like it is, okay? Let's look at another example of a synthesis of a metal oxide and water, okay? So we have lithium oxide. So lithium is +1. Oxygen is -2. Charges don't cancel, so we get Li2O, okay, plus H2O, okay? Which means my product is going to be lithium hydroxide, okay? So lithium is +1, hydroxide is -1, therefore this will be LiOH, and then I have to balance by putting a 2 here, okay? Last type of synthesis reaction is a non-metal oxide and water, and we make an acid, and the formula looks like this. Hydrogen's going to be up front. The non-metal, which is X, is going to go in the middle, and then oxygen is going to go last. And we literally count how much of each one of those things we have and put them together. So for example, carbon dioxide and water. So C is a non-metal attached to oxygen plus water. And I'm going to say I have 2 hydrogens, so I'm going to go H2, 1 carbon, C, and then 2 + 1 oxygens is 3 oxygens. So my acid is H2CO3, okay? So look at another example. Sulfur dioxide plus water. So sulfur dioxide is SO2 plus water is H2O. So I'm going to put them together, putting hydrogen first. So I'm going to say I have 2 hydrogens, so H2, S is going to go in the middle, so S, and then 1 + 2 oxygens is O3, okay? So that's it for predicting synthesis reactions. The second type I'm going to talk about is the decomposition, okay? Which is just going to be opposite that of synthesis, okay? So we have binary carbonates and chlorates here. So the first one we're going to look at is a binary compound breaking apart into its elements, okay? So for example, sodium chloride is going to break into sodium plus chlorine. Well, what do you need to remember about chlorine? It's a Hofbrinkel. So I need to put a 2 right there, okay? And then I need to balance. So a 2 here and a 2 here will balance out. The next one is rubidium oxide. Rubidium is in group 1. It's right here, since I have a periodic table in front of me. Rubidium is right here, so it's plus 1. So Rb plus 1. Oxygen is O minus 2. So this is Rb2O, okay? Which means I'm going to make rubidium and oxygen, okay? So I'm going to have Rb plus O2. And then the last thing I have to do is balance, and I'm going to do that by putting a 2 there, but I need to put 2 over here, so this is going to be turning into 4. Okay? Those are easy. Second one, it's takes a little bit more paying attention and following what you're given here, okay? So the next type of decomposition reaction is a carbonate decomposition, which means you're going to start with a carbonate, and it's going to break apart into a metal oxide. So the metal that's attached to the carbonate is going to now be attached to oxygen, and you're going to produce carbon dioxide gas. Okay, so let's look at an example here. So I have sodium carbonate. So I know right off the bat one of my products is going to be CO2. So I always write that one first, okay? And then since I took away 2 oxygens here, I have one that's going to be attached to sodium. However, I need to remember charges. So sodium is plus 1 and oxygen is minus 2, right? Charges don't cancel, so my metal oxide is going to be Na2O. So my metal oxide and my carbon dioxide. And then the last thing you do is balance, but most of the time these kind of balance out unless you have more than one carbonate, okay? Let's look at the next one. Calcium carbonate. So I'm going to make carbon dioxide and a metal oxide. So calcium is my metal. Calcium is plus 2. Oxygen is minus 2. So it's going to be CaO. And then I have to balance, but it looks like it's already balanced for me. Okay. Last one is iron carbonate. So one of my products is going to be CO2 plus iron oxide. So in this case, iron is 3 charged because of the uncrisscross. So it's going to be Fe plus 3 and O minus 2. Charges don't cancel. Therefore, this will be Fe2O3. Okay? And then I do have to make sure that this one's balanced here. Okay? So I have 2 irons, 3 carbons. So I'm going to put a 3 here. And then 9 carbons, 3 times 2 is 6, plus 3 is 9. So I should be balanced. Okay? All right, and then the last decomposition we can have is a chlorate decomposition, okay? In a chlorate decomposition, instead of making a metal oxide and carbon dioxide, we're going to make a metal chloride and oxygen gas. And you always have to make sure that you do O2, okay? So for example, if I see NaClO3, okay, all of that oxygen is going to go to O2. Everything else is going to be left over, meaning for sodium chlorate, I'm going to have all of the O2. So now all of the oxygen is gone, which means now I only have left sodium chloride. Okay, and you do need to make sure that your charges cancel. Sodium is plus 1, chlorine is minus 1, so they do cancel. Okay, and then the last thing you need to do is balance. Your oxygens are the only thing not balanced, so I need to make them both 6. So I'm going to put a 3 here and a 2 here to make them 6, and then a 2 here to make that balance as well. Okay. Next one, the decomposition of calcium chlorate. So I'm going to take all of the oxygen and turn it into O2. So I'm going to put O2 here, and then my metal chloride is going to be calcium chloride. Okay, so what I'm going to make is, so calcium is, why can't you see me writing? Okay, sorry about that. So calcium is plus 2, chlorine is minus 1, charges don't cancel, so my metal chloride is going to be CaCl2, and then the last thing you need to do is balance, okay? Chlorine is balanced, calcium is balanced, oxygen is not, so to balance it, I need to put a 3 here. Okay, so that's synthesis and decomposition. And then the last one is combustion. And combustion is really easy to predict because we're always making carbon dioxide, and water, always, okay? So let's just look at a couple of examples here, and then I'll let you do your practice in class, okay? So we have combustion of methane. So I'm always going to have CH4. I need oxygen in order for things to blow up. And I'm always going to make carbon dioxide and water, okay? Always. Combustions are the easiest ones to predict, okay? So let's just balance. So 1 carbon, so it's balanced. 4 hydrogens, 2, so I'm going to put a 2 here. 2 oxygens, 2 plus 2 is 4, so I need to put a 2 here, and I'm balanced, okay? Let's do one more together. Combustion of ethane, okay? So C2H4, so C2H4, or H6, in order to combust it, I need oxygen, okay? And I'm going to make carbon dioxide and water. They never change. Never changes, okay? So let's balance. So 2 carbons, 1 carbon, put a 2 here. 6 hydrogens, 2 hydrogens, so I'm going to put a 3 here. So 2 times 2 is 4 plus 3 is 7. Half of 7 is 3.5, but I can't keep the 0.5, so I'm going to say times 2. Times 2 becomes 2. Times 2 becomes 7. Times 2 becomes 4. Times 2 becomes 6. Okay? So thank you for watching this video, and now you are going to, and I wouldn't expect you to put your notes away and try your homework or your in-class work. What I want you to do is keep your notes out, and as you're predicting, use your notes as a guide to solve for your predictions. Okay? Thanks, guys.